Heyo, we're back for some more inequalities. Today we're talking about compound inequalities. So this is going to be part 1 of this 1.8 series. We're going to split this into 2 parts. Okay, so today we're going to be talking about compound inequalities. The next video we'll be talking more about interval notation. It's the same Common Core state standard. Solve linear equations and inequalities on variable. Okay. So let's jump down to here. A compound inequality consists of 2 distinct inequalities, that means 2 different inequalities, joined by the word and or the word or. Okay, so those are the keywords here, and or. You find the solutions of a compound inequality either by identifying where the solution set overlaps, where they overlap, or by combining the solution sets to form a larger solution set. The graph of a compound inequality and the word and contains the overlap. So and is the overlap of the graphs. The graph of inequality with the word or contains each graph, so both of the 2 inequalities. So it's both of them combined. Okay. So, for example, if we have x is greater than or equal to 3 here, we're going to start with a closed circle at 3. And it's greater than, so we're going to go to the right. X is less than or equal to 7, means there's a closed circle at 7 because it's equal to. If it was open, or well, I'll solve that in a second, but it's going to go left because it's less than, like so. And if we said both of those and, so it said x is greater than 3 and x is less than 7, then we would just do where they overlap. So if you look, they overlap here and here. So your graph would be from here to here. I like to make mine kind of squiggly so you can see them. Okay, so that's what an and inequality looks like. It would just be this shaded region here. An or inequality, so if we have x is less than -2, notice this is an open circle because it's not equal to. It doesn't have the equal to bar under it. So then we go left because it's less than. Ka-chow. This one is greater than or equal to 1, so it is closed. And it goes right because it's greater than. And if we say or, that means you do one going that way and another one going that way. You just combine them. You make both of them. Okay, you can rewrite a compound inequality involving and as a single inequality. For instance, in the inequality above, this one right here, you can write it as x is greater than or equal to 3 and x is less than or equal to 7. You can write that as this, as in x is between 3 and 7. So you can say 3 is less than or equal to x, and x is less than or equal to 7. Or you can say x is between 3 and 7 inclusive. Inclusive means it contains both 3 and 7. So because those are both equal to, less than or equal to signs, it would be inclusive. If it was just less than, then it would be exclusive. Okay, so let's try some of these. So what compound inequality represents the phrase, graph the solutions? Okay, so all real numbers that are greater than -2, so that tells me x is greater than -2, and x is less than 6. So greater than -2 and less than 6. So because it's an and, that means I can write it as a compound inequality. So I'm going to say -2 is less than x. X is less than 6. So that's telling me my x has to be between -2 and 6, exclusive this time, because it's not equal to. So to graph this, I'm not going to make a bunch of tick marks. I'm just going to make one at -2 and one at 6. Maybe one at 0 just for fun. And then I'm going to shade. I'll shade. I'm going to do it above it, but I'm going to do an open circle here and an open circle here. And it's just shades in between those two. Okay, it doesn't go beyond them because that's where they overlap. Okay, this one, it says all real numbers that are less than 0, so x is less than 0, or greater than or equal to 5. So x is less than 0, or x is greater than or equal to 5. So we can't combine those because it's not an and problem, but we can graph it. So I'm going to do one at 0, one at 5. That's more on there just for kicks and giggles. And then this one is just less than, so it's going to be an open circle. Let me do it above it again. Open circle, and then it goes to the left, like that. This one is greater than or equal to, so it's going to be a closed circle going to the right. Okay, and it is an or. Or should always point away from each other, and should always be going toward each other like that, and be in between. Okay. All right, I'm going to let you try these ones. See if you can answer A, B, and C. And then we will come back and talk about them. So go ahead and pause this, see if you can figure it out. In 3, 2, 1, pause. All right, so for A up here, I made it a compound inequality by doing this. X is greater than or equal to -4 and less than 6. So I did a closed circle at -4 and an open circle at +6, and I shaded in between them. On B down here, X is less than or equal to 2.5, so closed circle at 2.5, and it's going to the left. Or X is greater than 6, so open circle at 6, going to the right. And we just shade both of those. Now this is what is the difference between X is between -5 and 7, and X is between -5 and 7 inclusive. Well, if I was to write X is between -5 and 7, I would say X is less than 7, X is greater than 5, like that. But if I said inclusive, it would look almost the same, other than I put these equal to marks here. So it means it includes 5 and it includes 7. So that's the only difference. Okay, solving an inequality involving and. Okay, so this is a solution of a compound inequality involving and as any number that makes both inequalities true. One way you can solve a compound inequality is separating it into two inequalities. Okay, so I'm going to try this both at the same time. So what I like to do is just do this all in one step. So usually we want to get the m by itself, the variable. So in this case, we want to get it in the middle by itself. So we want to get this m by itself in the middle. Right now, the 4 is bothering it, so I'm going to add 4 to all three parts here to cancel out the 4 there. And that's going to become 1 is less than or equal to m is less than -1. So m is between 1 and -1. Just kidding, I didn't add 4. That didn't seem right. Okay, -1 plus 4 is 3. So m is between 1 and 3. So that means, and they are both, nope, just one of them is equal to. So I have 1 here, 3 here. This one's equal to, so it's going to be closed circle. This one's open circle, and we shade in between like so. So that's what that would look like. You just get the m in the middle by itself, and then shade from there. Okay, so go ahead and try this one. See if you can do it, and then graph it. Okay, pause in 3, 2, 1, pause. Alright, so I went ahead and solved this by adding 4 and then dividing by 3. And I ended up with y is between 2/3 and 6. Not inclusive, so exclusive. So when I shade that, or I graph it, I do 2 open circles on 2/3 and 6, because they're both not equal to, here and here. And then I just shade in between them, so like that. Alright, moving on. Okay, so this just kind of tells you what we did in the last one. This next one, it says to earn a B in your algebra course, you must achieve an unrounded test average between 84 and 86 inclusive. You scored 86, 85, and 80 on the first 3 tests. What possible scores can you get on the 4th and final test to earn a B in the course? So there's 4 possible tests, or 4 tests, and we need to average between 84 and 86 to get a B. So if we want to do an average, that means we're going to add everything up and divide by how many scores there are. So our average is going to be 86 plus 85 plus 80 plus our 4th score, which we don't know, so that's going to be x, divided by 4, because there's 4 test scores. And we want that to be between, so 84 and 86 inclusive, so less than or equal to 86, greater than or equal to 84. Okay, so the first thing I would do is get rid of the fraction line by multiplying everything by 4. Okay. So I got 336 on the left, 84 times 4, 344 on the right, 86 times 4. And then these are going to cancel. And then I would add up my like terms. So 86 plus 85 plus 80 gives me 248 plus x, because I can't add that x in yet. And then the last step, just subtract 248. And I forgot to keep my sign here. And then subtract 248 and subtract 248. So over here, that is going to give me 88 is less than or equal to x, because those cancel, is less than or equal to 96. So your score must be between 88 and 96 inclusive. So if you want to get a B, you have to get in this range. If you get, now don't get above 96 if you're getting an A. You don't want to look too smart. What's happening? No, it's still recording, I think. Anyway, if you get above 96, then you'll round up to an A, and we don't want that. Unless you do want that, then great. Okay. Okay, so again, same thing. It says, suppose you scored 78, 78, 79 on the first three tests. Is it possible to earn a B? So figure out if it's possible to earn a B. It says 100 is the max score. So using the same information before, so between 84 and 86 is a B. So try this in 3, 2, 1, pause. All right, so when you go ahead and do that, you get x's between 101 and 109. So if you want to get a B, you have to get above 100%, which in most cases is not going to happen. It says assume the maximum grade is 100. So in this case, you cannot get a B. You're going to have to settle for a C. Sorry, kids. All right. Okay, 2 more. And we're going to stop there. Okay. This one says a solution of a compound inequality involving OR is any number that makes either of them true. So to solve an OR, you must solve separately the two inequalities. So ORs are kind of simple to solve. You're just basically solving two different things. So we solve this one, and then we solve this one. So I'm going to subtract 2. That gives me 3t is less than negative 9. I'm going to divide by 3. That gives me t is less than negative 3. Or, if we solve this one, subtract 5, I'm left with negative 4t is less than negative 4. Divide by negative 4. And remember, when you divide by a negative, you have to switch the sign. So t is greater than positive 1. So t is less than negative 3, or t is greater than 1. And if we graph that, I have my negative 3 here, my 1 here. And none of them are equal to, so they're both open holes. They're going left on that one, right on that one because it's greater than. Okay, OR should always be pointing away from each other. All right. Okay, the last one, I'm going to let you guys try this, and then I'll do it as well. Make sure you solve it and then graph it, and then we'll come back. Pause this in 3, 2, 1, pause. Okay, so I solved each of those. The first one I got y is greater than 3. I had to switch the sign on that one. And then OR, on the second one, I got y is less than or equal to negative 2. So I graphed the y is less than or equal to negative 2 by doing a closed circle, and then going to the left. The y is greater than 3 is an open circle because it's not equal to, and then it goes to the right. So that's what your graph should look like, something like that. All right, okay, we're going to finish the next 3 slides in the next video, so it'll be pretty quick, hopefully. And then, yeah, then we'll be done with 1.8. All right, I'll talk to y'all later. Have a great time. Do well on your quiz. And I'll catch you all on the flip side. Adios.